introductory wise on the FCC licensing piece, a little bit on site selection, procurement, some of the cabinet and audit installations prior to going through and doing deployments, a little bit more on management and monitoring, as well as some O&M recommendations in this particular section, and then talk some more about Backhaul Communications and sort of the secondary breakout portion of the presentation. So just in terms of licensing for the RSUs, just to kind of make sure everybody's on the same page, FCC is definitely the governing agency. A number of the initial pilots are using, as Raj mentioned, that blanket use FCC agreement as part of the grant to USDOT. Any new sites or new deployments, you definitely need to request sort of those site-specific license details for FCC broadcast, and that would include any of the SPAT challenge locations that folks are looking to deploy or set up. So just as a 101, it helps to kind of do site selection, initially gathering GPS locations for potential RSU locations, do the FAA look at each one of those locations, make sure that everything is effectively a no hazard, and then ultimately work through the geographic license, and then once construction is complete and the devices are deployed, to go back through and do the certificate of construction for the FCC Form 601 and push that out for use and ultimately deployment for longer term setups. So we talked a little bit about channelization and effectively how these are broken out or set up for RSU deployments. So most folks at this point are setting up RSUs, and as part of that initial setup implementation by site, you may be looking at certain site-specific applications, as an example, like transit signal priority or signal phase and timing with the map messages, WSA broadcast, and each of those pieces or application sets would be used on specific channels. And so this is just sort of a basic breakout of that spectrum allocation and how folks would set up for those early style deployments for implementation. So some RSU design considerations. So in a number of projects and in different locations, deploying agencies or municipalities may choose to co-locate RSUs with existing communications and ITS equipment. That's totally probably a lower cost implementation method to help kind of consolidate where I've got equipment and how it's being used. That site configuration we'll talk a little bit more about in a moment. It definitely helps to know sort of the standards and specifications and ultimately applications that you're going to deploy as part of a SPAT challenge, sort of early deployment configuration. The USDOT 41A specification, or Release 5 for April of 2017, is a great kind of reference specification to use for procurement when you're looking at bringing in new RSUs to an agency. Mounting height is kind of one of those key aspects of implementation, and so you need to make sure that the maximum height is kind of coupled with the limitation for the antenna power, as well as roughly 26 feet above the roadway surface. As Raj was mentioning, and to kind of can't say this enough, the RSUs do function with clear line of sight. So where you choose to mount those within an intersection becomes sort of a compounding factor to the broadcast distance or coverage area that you might expect to get to equipped vehicles that would have onboard units or OBUs equipped within them. We're generally recommending that the RSUs be effectively a hard fixed mount to basically try to get away from sway or vibration. In a lot of cases, we found that like an 18-inch or 24-inch sort of offset to those strain poles or mast poles is kind of a ideal recommendation for installation. It helps to kind of go out when you're doing that site evaluation and select to look at spectrum analysis and see if there's any existing interference near the band or within the band, and in that way, when you're going through the FCC process, if there is interference within that band, you can bring that to their attention and check to make sure that that license that's broadcasting in that location is valid, or if there's, again, some other regulatory things that need to take place to remove that are done in advance of you deploying the RSUs out there and then not getting the effective coverage that you're really expecting for your specific project. As a detection range for the RSUs, somewhere in that 1,000 to 1,200 meter range, largely depends on antenna tuning or power, as well as site configuration themselves, and that will ultimately help with getting more effective basic safety messages and SPAT safety application messages out to the vehicles to improve how these are performing within project corridors. So this is an example of when you're looking for locations to do deployment. A lot of times we'll be looking at 3D surfaces or a combination of Google Street View and kind of mashing up a couple of different data sets to evaluate where an RSU would be best placed, kind of buffering each one of those areas in a sort of spatial manner to determine how much coverage or overlap might be being seen, and then you can sort of look to that trade-off kind of analysis through that decision-making process to move an RSU to a different location. Certainly if there's an intersection that is a safety critical location that has high accidents or a lot of vulnerable road user usage, those would definitely be what I would call critical drivers to installing an RSU in those site locations. Out along the freeways and those types of things, to kind of broaden out the coverage area, it helps to kind of have those RSUs spread out. And then when you're looking at data aggregation and bringing that back for analysis, it helps you to kind of have a broader implementation for through a corridor or a location set. Getting into some typicals for installations, again, kind of leveraging the strain pole for existing camera locations is a great way to go. Your roadway height, again, affects sort of the positioning of the RSU, as well as antenna placements. Different manufacturers have different implementation strategies for whether the antennas point down or point up. So those are some of the look at documentation and evaluation when you're looking at bid responses to evaluate what kind of site criteria a specific RSU manufacturer will require for installation. When you're looking at sort of a fixed location, a number of times we've found that, again, sort of this D-style connector mounted to the mast pole itself is kind of a good stable position to mount off of. It helps reduce vibration, and with the RSUs looking to get a good 3D or GPS fix, then at that point that helps with making sure that that unit kind of operates from a efficiency standpoint. In a number of cases where you're kind of, again, co-locating with existing gantries or your DMS sign structures, you want to sort of make sure that RSU's offset from the structure a bit to improve its performance, as well as get clear line of sight to the traffic that's live in that environment, and making sure that it lines up to the lane sequencing and is able to be deployed in those locations. When you're looking through on the cabinet side, it helps to establish as Raj was saying, making sure you've got space in the cabinet, that power is set up and ready to kind of be implemented. You've got effectively a spare power outlet to plug in and push to the power over Ethernet injector that a lot of the RSUs are requiring at this point. And again, we're kind of piggybacking on a number of different things at this point, but that the maximum Ethernet distance is roughly 328 feet to drive for both Ethernet and for PoE. In a lot of cases, we'd recommend that for remote sites or even for access purposes, if you've got a device that needs to be power reset, having a remote ability to do that is sort of a best practice recommendation, perhaps. So something like an iBoot would kind of implement or work in that scenario. For the traffic signal controllers, certainly the manufacturer or make, the model itself, and the firmware versions. Certain manufacturers are now sort of enabled to broadcast SPAT directly to an RSU and may not require a secondary piece of hardware sort of in that, I'll call it, broadcast scenario. So that helps from getting that message out to the RSU and reducing potential points of failure within that sort of safety-oriented broadcast for SPAT challenge sites or early deployers. Certainly, looking at the cabinet switch itself, making sure that the backplane supports the additional bandwidth and information load that will wind up happening from sending BSM forwarding from the onboard equipment units through the RSU and out to like a back office data aggregation spot, as well as sending signal phase and timing data from the traffic signal controller through that cabinet switch and out to the RSU. And certainly, one of those key sort of decision points for folks that are looking to early deploy or set up for SPAT challenge is, IP6 implementation, sort of pushing that through the infrastructure or through the sites that are looking to be early deployed versus doing sort of like an IP6, IP4 dual stack or staying in a pure sort of native IP4 deployment, affect both the equipment, the integration, the configuration themselves of each one of the devices, and to a certain extent, the total life cycle costs for deployment and early implementation. Kind of leveraging off or talking a little bit more about procurement. Certainly, leveraging the 41A, version 5 specification document from the USDOT is a great place to start. When an agency is looking at deploying early or new application sets, adding those pieces and components to the procurement specification is definitely a recommendation. SNMP version 3, in some cases the MIBs themselves are, again, a great place to start, but there may be other enhancements or modifications that might be needed for agency-specific implementation, and those pieces would be best kind of put in place during that procurement and evaluation process. In a lot of cases, as those standards that are in the marketplace are evolving, making sure that any of your standards references that are in the procurement documentation are current is a good recommendation. And then if you're going to go through and do selection criteria or any type of testing pieces prior to doing a procurement, that would definitely be a good element to add in the actual device specification before you release it out. In some cases, we've seen that certain vendors are adding sort of volume discounts. So if as part of your site selection criteria, your total unit quantity, it helps to kind of broadcast that forward in that procurement specification to help kind of drive down the total cost of implementation for deployment locations and any project-specific sites. Kind of jumping into state of health or management and monitoring. Certainly leveraging SNMP version 3 is a great place to implement from. With those MIBs that are being supplied from a number of RSU manufacturers, is a great implementation strategy to incorporate that into your management and state of health platform. Using DTLS to kind of add on a security layer for SNMP is definitely a recommendation in the long-term strategy. Certainly MIBs are maybe not always created equally and may wind up requiring fairly frequent refreshes, and a MIB from manufacturer A may not implement the same SNMP components or methods that manufacturer B implements. And so having that as part of that evaluation criteria in the procurement spec and any testing that you do before purchase is a good place to look at in terms of getting your best use out of implementation. So for a number of project deployments, we've implemented a cloud service, SNMP methodology. So at that point, you can add hosts to the implementation. There's some flexibility in terms around adding custom MIB support to that. This is very similar to the platform that we're leveraging for the Ann Arbor Connected Vehicle Test Environment. As you drill a little bit further down into the application suite, you can look at site-specific or corridor-specific devices. Each one of the application pieces that are key for that management and monitoring evaluation, and looking at when a failure occurs, how far into the application or the RSU do you need to take a look at to assess what's going on with it versus just sort of straight up knowing, hey, look, I've got a communications backhaul failure along corridor X. And so that helps to kind of quickly assess what's going on as you ramp up or scale up the number of RSUs that would be deployed within an infrastructure or for a client. When you look at drilling down sort of the next tier within the application set, you can take a look at the combination of application components that ultimately are successfully running, and that again helps kind of aid in that troubleshooting process to assess what's going on with the unit at that point in time. From an O&M recommendation standpoint, certainly the standards and knowing each one of the critical pieces is a recommendation. So from J2735 on the SAE side, knowing the IEEE 1609 2, 3, and 4 standards is a key element. Looking through if I'm going to take and bring in data from OBUs that are traversing my corridor and store them for the long term, what data elements out of part 1 and part 2 do I want to store, and do I want to implement that all in one chunk or break it up into sort of phased implementation, goes to the storage strategy and ultimately other application uses as that data set becomes richer and more deployment sites are implemented across an agency or a project area. And certainly, as Blaine was talking about early on, a number of early deployers have looked at and implemented onboard units for use in multiple fleet vehicles that may traverse a corridor. It helps kind of fill in data for that specific corridor. Also helps if you're trying to demonstrate and get sort of leveraged value out of that early implementation to your stakeholders or to your executive management, because nothing says like this is working when you can actually see it on a heads-up display inside of a vehicle and you're seeing that sort of dynamic data change in real time. It helps sort of solidify the implementation and the benefit of doing this as an agency. And certainly bench testing, interoperability testing between devices, while OmniAir is coming online with test laboratories and certification, testing, and Turner Fairbanks is working on their testing pieces as well. Certainly any new applications that are kind of coming through the market space, it's still kind of a good recommendation to evaluate those testing configurations and integration parameters that are specific to your agency prior to going out and doing field deployment. Getting a little bit into the backhaul communications piece, there's certainly opportunities to leverage what's out there in a number of locations. Being able to broadcast secure and encrypted messages, attaching to production certificates via the security credential management system is a key to maybe where we would like to go as a market or as an industry in the long term. The sooner we can start kind of implementing those for early deployment locations helps from a certification standpoint, from a validation standpoint, as well as from a, I call it an IT professional standpoint of helping to secure the RSU as a new network device on the edge of an agency's network. So the more sort of security layers that I can add to the broadcast and the overall implementation helps from making this a more stable environment that is harder to penetrate or to hack through and become a bad actor for a deployment. And certainly, there's a role in that backhaul communications aside from the security aspect, but to get data back to a back office, and whether that's within a TMC or even out to the US DOT or like the operational data exchange or something to that aspect, sort of leveraging that CVRA implementation are opportunities to kind of leverage that with the backhaul communications, as well as supporting remote configuration and troubleshooting. So that way I don't have to physically be on site with the RSU and the cabinet door open, plugged into the network switch in order to figure out what's going on with it, or to change a configuration parameter or load a new message set for broadcast deployment. As a real quick kind of touch on security, there's certainly PSIDs that are being managed as part of the registration authority on the IEEE side. Those PSID numbers have an effect on how I advertise services that we were talking about in the early part of the presentation today, where like WSA might be for my agency on channel 172. Those PSIDs kind of combine with that to make sure that the OBU is also listening to the right channel and being able to respond correctly. And so that all kind of ties in with SCMS, the messages set that I ultimately deploy on, and how those PSID numbers are implemented for those specific sites and applications. So through the Camp LLC organization, they have a live wiki site. There will be some reference links towards the end part of my section of the presentation, as well as this site link, that help kind of lay out some of those breadcrumbs and kind of put the pieces together in terms of which applications and what message sets would be broadcast with which PSIDs, and those wind up needing to be kind of included with my procurement specification as I'm selecting devices or evaluating things. So there's definitely, I guess, really the first in production use of an SCMS provider we've been working with has been Greenhills. There are a number of network pieces that wind up needing to be put in place to allow the RSU to communicate with the SCMS. So implementing TLS on the network, allowing port 443 traffic in and out of the network through to the edge device is an important implementation piece for this to work. So far we have used IP6 native on a number of projects, and that has worked well. There's an IP4 element of this that can be deployed. We specifically haven't tested that on our end yet, but that may be other pilot locations that could speak to that much more in depth, perhaps. own the long term, it may be good to look at the commercial terms and service level agreement pieces for Greenhills if you're going to implement a number of RSUs at scale and tie them to production certificates. So that might be something to kind of recommend looking at with your legal staff to make sure that all of those pieces line up for your specific agency. Like a number of things, price, performance, and implementation requirements for new providers as they enter the market are likely to have variables or variances in how those affect integration and deployment. For a number of RSU deployment projects, we've implemented PSIDs by application from that IEEE registry, and this is just some of those PSIDs by application. So there's some breadcrumbs for folks if you're looking for what some other folks have used or implemented in the past. As a real quick data transfer example, so when I have a OBU deployed in a vehicle, I'm ultimately broadcasting SPAT and MAP from the RSU out to the vehicle itself. The BSM and probe vehicle data message would respond back and be able to pick up from the channel assignment on the WSA that's also broadcast from the RSU. If I have an RTCM or real-time correction message, that would be deployed and broadcasted from the RSU out to the vehicle itself. The signal controller would be sort of the master source of the raw SPAT message. It could, in a number of cases, directly output to the RSU without a third-party hardware. In a number of cases, you could implement with the connected vehicle coprocessor or the V2I hub as a intermediary to forward SPAT to or send the SPAT message out to the RSU to ultimately broadcast that out. Where I'm implementing a backhaul communication, I would ultimately have an ISP connection that goes out to the internet and allows connection to SCMS to an off-site back office data analysis location, or if it's inside the network, that could be at the TMC off the back-end switch at that location. Certainly a firewall and packet inspection could be implemented at that sort of head-end location and implement security for within that sort of data transfer all through the DOT or the municipality network itself. So, how do we look at remote messages? So at some level, the configuration of WSA could be done through SNMP or through SSH to the RSU, and then that would ultimately be sent out to the OBUs or broadcasted out. The probe data message, in terms of configuring what the vehicle will respond with if it's implemented with a probe vehicle data message, that again could be configured through the RSU itself or via SNMP remotely and then broadcasted to OBUs. The signal phase and timing data would come from ultimately the traffic signal controller through to the RSU, be combined with the MAP broadcast, and both of those pieces broadcast out again to the OBUs themselves. The traveler information message would be a remote message, or could be a remote message load with a start and stop time that then gets broadcast within those parameters to the OBUs. In a number of cases, the OBUs are very, very remote. You may not be configuring those parameters kind of remotely. Most agencies would set those OBUs inside their fleet vehicles and update firmware from within a maintenance shop or some location like that. And once that firmware has been updated and tested, then at that point I would kind of push those across multiple fleet vehicles, and then when they're out traversing the roadway, get into a coverage area for an RSU. Now at that point, those BSM messages or signal request messages get sent back to the RSUs, and whether I have forwarding enabled, those RSUs would again send that message set on to a back office data aggregation point. There's several options. There's several folks that have developed configuration and monitoring tool sets in terms of being able to configure a message and send it to an RSU. The US DOT data warehouse tool, as it stands, will enable you to kind of create those map and TIM messages through that methodology. In the cases where you need a higher resolution LiDAR data set to get much richer positional accuracy for the map message, those pieces would be done offline via a toolkit, post-processed, and then the map file created and then deployed for the RSU in those locations. And then if you want to go through and testing and validation purposes, the camp verification document helps from that, what you would see in the in-vehicle device that's deployed and set up to make sure that those pieces are functioning properly at that higher resolution deployment aspect. So in a number of different backhaul scenarios, several folks or projects have implemented with shared use fiber. Some folks have implemented with a mix of fiber and wireless. And then in some deployment scenarios, they've been an all wireless scenario. So we'll just kind of real quickly touch on those pieces just to kind of show some folks what that may look like. So in Ann Arbor, it is a native IPv6 implementation on mostly agency fiber. There are separate VLANs that are structured within the network to protect, we'll call it inside traffic from connected vehicle traffic. So each one of the cabinet locations would have an RSU connected to a cabinet switch, and then ultimately the traffic signal controller would be connected to the same switch, and then those messages get sent to the RSU and broadcasted out. Connections to the SCMS and to your back office data aggregation is done through the city network out to a head end with a new firewall and router implementation and an ISP connection. So that way, from a bandwidth standpoint, there's no impact on, we'll call it the enterprise network for the city. And as we roll from 30 RSUs that are deployed within this configuration out to 80 RSUs, that bandwidth allocation or usage winds up being a critical driver to how this gets implemented at scale. The SCMS provider is a connection via the internet itself, so that's how those pieces are done. So each one of the RSUs are able to go through the city network out to the internet, reach to Greenhills via TLS, get a new certificate and pull that back and load it onto the RSU. Or if there's a scenario where there's an OBU that needs a top-off certificate, that request can be made through the RSU and kind of same topology path out to Greenhills to get that new production set of certificates loaded and topped off for an OBU. As an example of a wireline and wireless example, a number of folks have implemented ring networks and had RSUs at certain sites within the ring. So the network itself is redundant or resilient, and that provides a communication pathway to the RSU from a traffic management center. So if I've got data storage at that location, at that point I can send that through the network core out to the agency back office, where we've got wireless implementation out to, we'll call it remote nodes on the network. That still allows those RSUs that are deployed within those nodes or sites to communicate back with the network core. And so that's a different kind of strategy to implement or broaden out where I've got RSUs deployed within my network from a backhaul communications standpoint. One of the last examples we want to kind of talk through a little bit quickly is an all wireless scenario. A few folks have implemented with RSUs on cellular communications, and certainly that's an effect to the overall data plan itself as an agency and usage on a site-by-site basis. So you want to take a look at sort of that cost model for your wireless agreement or your carrier that you have access to from the agency side. Where we've got wireless Ethernet that could be deployed from a site-to-site standpoint through a corridor in place of fiber or copper wireline, that could be an implementation strategy to kind of again access a backhaul communication standpoint for the RSUs that would be deployed within each cabinet location. And then as those get backhauled up to, again, a back office location, those would then be accessible via the internet from an ISP connection through a firewall and a router into the TMC or a back office location. And whether I set up a test RSU at that site, that's again sort of an agency deployment choice at that point. If I want to equip a location that is closer to me from an early implementation or testing new applications as they bring those into my environment is an opportunity. And so with that, I'll kind of wrap up. These are some reference resource links to certain standards and documentation that's available to